Hello everyone, we are Group 8 of CHE 201 course project. Our topic is type of pressure gauges. Let's dive into it. Based on the working principle, we can classify pressure gauges into different types. First one is mechanical pressure gauges. Examples are Bourdon tube, diaphragm, and bellows. Other one is liquid column gauges. Examples are manometers. Third one we have is electrical gauges. Examples are strain gauge, piezoelectric, and capacitive gauges. And last one is digital gauges. Examples are smart sensors. Moving ahead.
Modern tube pressure gauge, it is a mechanical gauge. It has a curved tube and it shows tip movement, which gives us the pressure reading. It can measure pressure up to 7,000 bar, and it is used in steam boilers, compressors, and hydraulics. Which straightens up upon acting of pressure by the fluid, hence transferring the motion to pointer and showing a visual indication of pressure, which is directly proportional to the pressure exerted by the fluid.
Then comes diaphragm pressure gauge. The pressure application is basically applied to the diaphragm. Then the diaphragm deflection is directly proportional to the applied pressure. And diaphragm pressure gauges are mainly used in low pressure measurements like in gas pressure measurement, vacuum cleaner, etc. So it has various applications. The main principle is basically expansion and contraction of with pressure changes. It's constructed with a metal cylinder composed of brass, bronze, and stainless steel. It operates on the basis of a pointer and sensor output. It typically works within the range of 0 to 1.2 bar. And main application of low pressure gauges are HVAC systems, vacuum pumps, and instrumentation. Moving to the next slide.
This is a manometer, a simple device used to measure pressure using a liquid column. It works on the idea that height difference of a liquid shows pressure difference. Mercury is used for high pressure since it's dense, while water and oil is used for lower pressures. There are mainly three types of manometers: U-tube manometer, inclined manometer, and differential manometer. Overall, manometers are low cost, easy, and reliable. Moving to next slide. Dead weight tester. A deadweight tester is used to check and calibrate pressure gauges. It works on the force divided by area principle. When we add known weights on a piston, they create known pressure. This gives very accurate readings, which are used as standard to test other instruments. It is one of the most trusted tools for maintaining pressure accuracy.
Here in this slide, we discuss about this chart, which shows various type of used in pressure like industrial control network, sensor, processor, IoT connectivity, cloud platform, and here is digital smart gauges. This is the figure. Now moving to next slide. Strain gauge pressure transducer. The main principle is pressure deforms a diaphragm, cause strain on cause changing resistance. Here is the specific formula, and here is a mechanism for working. Application is used in industrial control, robotics, and aviation. Definition: electronics device converts pressure to electrical output. Now moving to next slide.
So next is piezoelectric pressure gauge. It contains piezoelectric crystals. These are the core crystals that produce voltage under pressure, and these gauges are also used to measure pressure in combustion environment. These also detect and measure shock wave pressure. It also has a fast response time, and it is also used in engineering. Next slide. So here is a comparison between all these gauges. So as you can see that Bourdon gauge has a higher pressure range, and whereas diaphragm pressure gauge has a very low range, whereas the strain gauge has a very high accuracy of 0.1%, whereas Bourdon and Bellow pressure gauges have a very high accuracy of 1%. And also, these are the selection criteria: range requirements, accuracy needs, environmental factors, and cost versus performance.
This slide talks about the real life application of pressure gauges. They are used in automobile industry for engine oil pressure and air brakes, in the medical field for blood pressure monitors and respiratory equipment, in domestic appliances. They are used in heating, water system, and gas cylinders, and also for recreation and safety, like in case of scuba diving and fire extinguishers. Next slide, please. So to conclude the selection of pressure gauges, this slide highlights the key factors to consider when selecting and using pressure gauges in industrial appliances, such as reliability and accurate pressure management measurement. It also includes factors such as selecting the right pressure range, accuracy, and environmental condition for adopting digital sensors to contribute in better monitoring and durability.